I discovered, and I also found that out to be true in the other two calc classes, that there are these two definitions of the derivative which people are having some difficulty reconciling. Okay? And I'll show you what I mean in just a bit. Here is the basic picture. The function is graphed in green, right? This point is fixed. This is our point P, A, f of A. That is not going anywhere. That is the point at which we want to find the slope of the tangent line in order to be able to get the equation of the tangent line. Am I right? Because presumably that's important, not a trivial exercise. Well, you can't get that off of one point. You need to somehow do something. So the clever idea was, wiggle a little bit to the side, pick another point. Now you got two. This other point is A plus H. So this is, let's call it Q. Well, I made green to draw a distinction. I know I'm blocking with my derriere here all because I'm thinking of the work that Jesus helped us with yesterday that stuck in my head. We've got to do this. This point is variable. This is moving on purpose. Because the grand idea is to let this point wander down to that point, and then the connecting segment is going to have a slope that's bluer and bluer. It's almost a tangent, right? You get the tangent by letting this guy wander here, and at each stage the difference becomes less and less, and the slope of the black becomes the slope of the blue, which is what you're like looking for, right? And that wandering can be achieved by letting H go where?
To zero.
To zero. You all see that? If H goes to zero, this shrinks, right? So it's like a clever idea, isn't it? Some people are talking and not listening. Okay, you're not only dissing me, you're dissing like Isaac Newton, one of the greatest brains that ever lived. All I'm doing is paraphrasing what he said. I'm walking in his footsteps. Shame on you to do that. All right, so the idea is, the slope of the tangent is the limit, as h goes to 0, of the black slope here. F of A plus H, that's this guy here, F of A plus H, that's, if you will, this vertical. That's Y2 minus Y1, here's Y1, F of A, all over X minus, or all over H, I should say, because that's rise over run. This is just H. Isn't that right? Say yes.
Yes.
Louder.
Yes.
Okay. All right. Now, the equivalent way of saying this is the limit. And this is where some kids are getting hung up. F of, call this here x, A plus H, call that x. F of x minus this vertical still, F of A. And then this distance here, from here to here, isn't h anymore. You know, h is x minus a. You all see that h is x minus a?
Yep.
If x is a plus h, then h is x minus a, right? Okay, so I could go over here. You see that saying the same thing in another way? You know the concept of a synonym in English? What does that word mean, synonym? A word that means this? A little lame, goodness. What does it mean? Same, right? So this is two different ways of saying the same thing. The high point of our period yesterday, I thought, was when Jesus came up and did that problem. And it turns out that it was problem 1, and there's a problem 2, which is this baby here, which we have to reconcile. All right? To remind you of what happened yesterday, because again, that was great. This was problem number 1, I think, on this work here. You had f of x is 1 over x at x equals 3. and Jesus did this, f of x plus h, excuse me, 3 plus h, x is 3, or here it's a equals 3. F of a plus h would be 1 over 3 plus h minus f of a. F of a is 1 over 3 over h. And he worked this on down and worked it on down. Does anybody remember what number he got? Uh-huh. Excellent. Negative 1 over 9, which he did right, with all the steps, all the bells and whistles. That was this. If these are in fact synonymous, by the way, this should be x goes to a. I said it but didn't write it. H goes to 0 means x goes to a, right? Okay? Bless you. H goes to 0 or x goes to a. All right. This should give the same answer, and that's problem number 2. Let me get this out of the way here. Soon to return. Because we want to dignify this. If we don't know this stuff at the beginning, then we're going to have all kinds of difficulties later on. Whereas if we learn this now, then we're business. I need somebody to substitute in this and turn the crank and see what happens. I need a brave person. Even if you make a mistake, we will help you. Let us start, and maybe some people can chime in from their seats. What is A here?
3. No, x is 3, a is just there. So just be 1 over 8.
What's f of x?
1/3.
1 over x. F of a?
Oh.
1 over 3.
Okay.
1 over 8.
Okay. In our particular problem, though, we're supposed to do it at x equals, at a equals 3, right?
No. It's switched. F of x is 1 over 3, and f of a is 1 over 8.
No. So isn't it f of x minus f of a over x minus a?
Yes.
So x is x, and
No. In the book it says find the derivative of f of x equals 1 over x at x equals 3.
that's it. That's what I'm doing. Now let's see if it matches the definition.
You're right, Mr. Bukowski.
Oh, you just give me a political answer. I may be right, but we have to go by what the book says. Let's look at page 96 and then let's see. We did it right. A is 3, so I put 3 over here, I put 3 over here, put 3 over here in the definition. See, I don't get to be right because I'm older, taller, or whatever, male. I'm right, if I'm right, I'm right because it matches the definition. Sonny can be right too. Okay, now? Okay, cool. This is still laden with problems because as x goes to 3, doesn't this go to 0?
Yes.
Do we have to take the limit like right away? Major idea. No, we take the limit where we're ready to take the limit. We don't have to pull the trigger, pardon my verb, right away. What we have the option of doing is doing as much algebra as we want and transforming this term until we're ready to meet this requirement.